Hello? Hello? Okay, hello guys, hello. So, how's everyone? Everyone doing good? Okay, so good afternoon guys. Okay, before I start my presentation, I want to first introduce myself. I'm Michael, one of Walletbeat's contributors. If you've seen me on X, you've probably seen me posting as MatMat. Okay, so let's talk about Ethereum wallets. First, I want to ask two questions. Who here has used an Ethereum wallet before? Okay, so it looks like almost everyone here has used an Ethereum wallet before. And now my second question is, who here has signed a transaction before, before fully understanding what it does? Okay, I see. There's still a few hands. That's nice. So I'll be the first one to admit it. I have signed more than one transaction without fully understanding what it does. I know it's kind of embarrassing, but transactions such as Uniswap transaction or CowSwap transactions, I think it's quite common in our space, right? Most of us here has used an Ethereum wallet before, so that's exactly why wallets matter. And other reasons why wallets matter is that number one, it holds your keys. Two, it holds your funds. And three, it enables you to sign transactions. So with all of that being said, your wallet should at least be secure, right? I want to ask you guys what wallets are you using. Please raise your hand if you're using Ambire. Any Ambire users here? Okay, I see a few. How about MetaMask? Okay, MetaMask. It's the most popular. How about Rainbow or Rabi? Okay, I see. Safe? Okay, so with all of that being said, these are all great wallets. They have been battle tested, and these are the wallets we've known throughout the years. But here's the thing. It doesn't matter if you have the most secure wallet if you don't know what you're signing. Well, you guys remember the Bybit hack? $1.5 billion got stolen from Bybit. It was not a vulnerability exploit. It was not a smart contract exploit, but it was a result of blind signing. Now, this is not an attack on Bybit or any of these protocols, but because the current wallet landscape makes it difficult for users to understand and verify what they're assigning. I think we have a transaction legibility problem. Now, what is the transaction legibility problem? Users do not actually know what they are signing. Users experience things like horrible raw call data experience, which leads to poor hardware wallet transaction verification, and then users would just YOLO sign or blind sign. Now, luckily for us, this is where ERC-7730 and ERC-8213 comes in. ERC-7730 helps you understand what you sign. On the left side here, we have the raw call data. This is a supply transaction. And on the right side, this is the human-readable transaction that ERC-7730 provides. Users need and want the one on the right and not the ugly thing here on the left, right? But the way ERC-7730 works is that for whenever a project or a smart contract developer deploys a contract, you would need to register it to a registry, which is right now kind of a centralized registry. It's a GitHub repository. Funny story about this is I was actually planning on deploying my own contract and showing how ERC-7730 implementation works. But looking at how many PRs are still not merged just for project registry, then I might as well not. But the key thing is, if your project is not registered in the registry, means no ERC-7730 implementation. And this is where ERC-8213 comes in. ERC-8213 provides the call data digest that you can see on the right, which is much easier to verify than the 330 character count, which is the same Aave supply transaction we have earlier. I would still consider this as a short call data. Imagine if you're signing things like Uniswap or even safe transactions, then you will probably appreciate the byte32 digest, right? ERC-7730 helps you understand what you are signing, and ERC-8213 helps you verify what you are signing. The key message is this: wallet user experience and wallet security are increasingly becoming problems of standardizations. But What if more wallets start to adopt both standards? What do we get? We get better wallet interoperability, better wallet transaction clarity, better user trust, and better wallet safety, and also better open competition. Almost better everything. Now, the question to ask is, what wallets adopt these standards? What wallets implement certain EIPs or certain ERCs? What wallet provides basic user safety or user privacy? And this is where Walletbeat comes in. So, Walletbeat is a wallet rating system for Ethereum wallets. We are the L2Beat of wallets, and we evaluate wallets based on 5 dimensions: security, transparency, privacy, ecosystem alignment, and self-sovereignty. Walletbeat aims to raise the bar and push the wallet ecosystem forward. Now, one of our most recent implementations is now that we're tracking ERC-7730 and ERC-8213, or the wallets that implement them. And alongside with this is we've built a Walletbeat testing playground, which you guys will be playing around in a while. I'll be demoing it to you right now. So, to go to the Walletbeat testing playground, first you have to go to the Walletbeat page. It's beta.walletbeat.eth.limo. I know it's a handful. And then afterwards, you navigate to the sidebar, test your wallet. And then before you do anything, you must connect your wallet. But please take note that you should just use the seed phrase that we've given you. Walletbeat won't be responsible for any losses or any drains. Okay, so now I'll be doing the demo. Okay. I'll connect my wallet first, of course. Okay, so we have multiple tabs here, but we'll be focusing mostly on transaction simulations and scam alerts. So we have transactions, signatures, EIP support, app isolation, transaction simulations, scam alerts, and our most recent tab, ERC-8213, which helps you calculate your call data digest, and EIP-712. Okay. So what I love about MetaMask is that they handle transaction simulations properly. Let me show you what I mean. Here we have a volatile outcome transaction. And not only does MetaMask simulates a transaction for you, but after a while or after a few seconds, it resimulates a transaction again. As you can see, MetaMask shows you that you'll be sending 100 tokens, but after a few seconds, hopefully it shows, there you go. It shows you that instead of sending tokens, you'll be receiving tokens. And checking out your wallet's transaction simulated feature is very important, especially when it comes to transactions that depends highly on variables that are always changing. So scammers could utilize these kinds of transactions by creating a D app and then letting wallets only simulate a certain block number and will show you what looks like a perfectly normal transaction. Then during the execution, would execute the malicious state. So let's move forward to one of the other tabs, scam alerts. What I also love about MetaMask is that whenever you're trying to sign an unlimited approval, it shows you a warning. So it's already 2026, right? So unlimited approval is not required anymore. Please ask your wallets to have batch transactions to remove this necessity. And then one last tab I want to show you guys is EIP support. So this tab essentially tries to scan your wallet if what EIPs do they support. It's quite straightforward. You just have to run through 6 different steps. I'll show you guys. So run step. And on the 5th step, it will ask you to sign a transaction. Let's just assume that this transaction pushes through. And then afterwards, it will show you that a test result of what the test has gone through. It will either show you a passing rate or a partial rate and a failing rate. So a partial rate means a wallet implements all required and optional features of the certain EIPs. For example, this one, EIP-6963 and EIP-1193, the wallet implements all required and optional. And for a partial rate, it means a wallet implements all the required features of the EIP, but not all optional features of the EIP, and that's okay. And for the failing rate, it means that the wallet does not implement all the required feature of the EAP. Walletbeat only cares about wallets implementing or wallets having a passing or a partial rate. So now, please feel free to work around with the Walletbeat testing playground. Polymutex will be distributing sheets of paper that has a seed phrase in it, and we've prepared a little activity for you. Yeah? Hello.
Hi, thanks for the great introduction.
Uh-huh.
You said instead of unlimited approval, just ask wallets to do batch transactions. Can
Yes.
you explain why that solves the issue? So if I want to give approval so that I don't have to every time I go on CalSwap approve a specific amount, usually I just do unlimited approval, and in the future it will just accept my USDC without asking again.
Well, yes. I think part of why unlimited approvals was accepted in the first place was because we were forced to have two different transactions. Before it was approve and swap for Uniswap, correct? But now, through batch transactions, we remove that friction of having to approve two transactions by batching them into one transaction.
Ah, okay, that's what you meant. Okay, thanks.
Any other questions? Okay, so again, guys, feel free to play around with the wallets, and we'll be back after 10 minutes. So I'll be here to roam around and assist you guys as well. There you go. You guys need any help?
Yeah, I'm going around the playground and I see here a lot of example transactions that I can send.
Uh-huh.
Oh, maybe the point here is that the way you see it on the
Exactly.
wallet.
Yeah. See how it reacts and any comments, any feedbacks.
It's like fake.
Oh yeah, I think that's because you don't have any USDC, so feel free to swap. The five, I think 0.0058 is all yours. Feel free to play around with it, do swaps, anything you want. Do you need anything here? Do you need any help? Play around with the wallet. Okay, so also visit the Walletbeat testing playground. And then just check how your wallets react to different certain scenarios or situations. And hello?
Hello.
You need any help?
So far, so good.
Okay, so
I loaded one wallet.
uh-huh.
Okay, what's the next step?
Just play around with the wallet actually. That's the whole point of the Walletbeat testing playground. So I'll
Okay. Sorry, I did it on a fresh wallet.
Yeah.
You wanted me to do it within Walletbeat.
or any applications that you want.
Okay, so I use Brave Wallet.
Okay, did you import the keys?
Yes.
And does it show that you have tokens?
No.
Okay, so question is why? Can you try the other one?
Yeah. But usually you can have, it gives you a lot of addresses. So maybe it's not detecting the right address where there is money, no?
Well,
So for example, with the seed on MetaMask, if I load my seed on MetaMask, the first default address it will give me might not be the one that I actually use.
okay, yeah, but did you use this set or
Yeah,
okay?
No.
Is this mic available? Hello, 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 hello. Hello, guys. Hope you guys had a lot of fun exploring your wallet, exploring the Walletbeat testing playground. But for now, let's take a look at the screen again. Okay, so we've discussed earlier both standards ERC-7730 and ERC-8213 and how it helps the whole user signing experience. But what does it really look like in real life? So I'll be doing demo on how it would look like, okay? So context on the transactions I'll be doing is that I'll be doing an AV supply transaction through safe multisigs. And I'll be comparing three wallets. One wallet that does not implement both ERC-7730 and ERC-8213. And another one, a wallet that implements ERC-7730, and a hardware wallet that implements ERC-8213, and see how it really improves the whole user signing experience. Okay, so for the first transaction, I'll be using Phantom. Phantom has 5 million users for I don't know what reasons, actually, because you can see in a while what I mean. Oops, not Amber. Okay, so this is the same transaction using now Phantom. So okay, so not only it fails to simulate the transaction, but also it provides zero data at all. We can see here in the raw call data, we can see here in the transaction details, it only provides the raw call data, which users have no idea what they are gonna sign, or it will be even almost impossible to verify. But now let's compare it with the wallet that implements ERC-7730 or human readable transactions. Okay, so as we can see here, it's now more understandable and it's now more easier to verify, correct? So it says here that you're executing a safe wallet transaction, but not only it decodes the safe transaction, but it also shows you that you're going to be doing a supply transaction on Aave. So this is what users need and this is what users want. And now let's take it a step further and let's try to verify it on a hardware wallet. Unfortunately for us, we still don't have any hardware wallet that, or sorry, a software wallet that implements ERC-8213, but let's just use our imagination for in the meantime. Let's calculate our own ERC-8213 digest. This is still the same transaction that I will be signing, the same transaction earlier. It might take me a while. Okay. Okay, now I'm computing our own call data digest since Amber doesn't have one. Let's just imagine that this call data digest we have here is implemented in the Amber itself. And now I need someone from the audience to help me verify itself. Any volunteers, please? Any volunteers to help me verify this transaction? It will be easy, I promise. You? Okay. Okay, nice. What's your name, by the way? Sorry?
Hello, my name is Sebastian.
Okay, please give a round of applause for Rasha.
Nice
Okay,
meeting you.
Mike, nice meeting you again. Okay, so have you used a hardware wallet before?
I might.
I might. You haven't. Okay, so I might convert you. Okay, I'll just scan this QR code here. Okay, so the way verifying transactions on a hardware wallet works, normally users would look at this call data and verify it every character. So you can just imagine how tedious and almost impossible this process is, correct?
Doesn't look like fun actually.
Yeah, exactly, right? So, and again, this is still a short call data. So imagine a longer call data, right? Almost impossible. So with the help of ERC-8213, which is this thing right here, is this better?
This is way better, actually.
Yeah. Okay. So can you dictate character by character?
Yeah, I would
Okay.
be
so
able
yeah,
to do it.
Let's do it. Okay. I'll place it here.
Should I read it?
Yeah. Sure.
Okay. So it's 0x0FD57BCA 0E23 2BDD84A9. So it continues for a while now, I think so.
It's okay. It's okay. Okay. So the whole you can continue.
Once again,
Yeah, you can continue from A9.
it should continue, okay?
Yeah,
7B 187041 F9F19. So I think it's yeah. Should I continue till the end? Or
Yeah,
is
sure,
this
sure,
the
let's
goal?
continue till
Okay,
the
okay, like guys. So listen to me reading numbers and
Sure.
letters today.
We have all the time.
9F19 D1 CA 5639 EA5 75 CC 1 EE 6 CFC 693 0 BB4.
Okay.
I made it.
Okay. Thank you. Thank you again. What's your name again?
Sebastian.
Okay. Thank you, Sebastian. So, while it might look tedious, the way we have it normally works is that before ERC-8213, we have to verify pages of call data. So this is what we have now. And as you can see, the Byte32 digest is a much, much bigger improvement from what we have originally. Okay, so going back, standards like ERC-7730 and ERC-8213 aims to improve user experience and interoperability. But again, standards will be useless if not widely adopted. And as part of the ecosystem, Walletbeat will be playing its role to push wallets toward better standards, better interoperability, and safer user experience. And if you like this workshop, please feel free to follow us on our socials and give us a shout out. And thank you guys.
Thanks. Because we didn't get that far on here, but did you show before that there is a button I can press if my wallet does not have it, that it automatically sends a message to the wallet?
Sorry?
Like, I thought before you were showing something where if the feature or like they're not, they've not implemented any of these standards, there was something on your website that would allow me to send a message to the wallet and make them aware of that gap, or did
Well,
I imagine
no,
that?
I think what you're talking about is the call data digest that we calculated through the Walletbeat testing page. Is that it?
Sorry, say that again?
Yeah, so
Okay.
yeah, I think that's it. No, I'm just trying to show the possibilities of what it would look like if a certain wallet implements the standard, the call data digest, in which for now we have to improvise.
Okay, but if I find out that my wallet does not do any of that through your tools,
Uh-huh.
like, and you say like make sure that your wallet does have these features, I have to contact them, or what's your call to action?
Well, that's exactly the mission of Walletbeat, is to making these wallets care, especially for these standards and values. So we would like your support to rally around these standards.
Okay.
Okay.
All right.
I'm afraid that's all the time we have for today, so thank you once more for our speaker.